All right. Well, welcome to Optimal Road. My name is David Hernandez. I'm a part of the Illinois Mathematics and Science Academy. This is my seventh year here at IMSA. Before IMSA, I was in the classroom for many years with my math and science middle school and high school. Today, we're going to focus on middle school math. Hope you like it. And now we have my friend Preston, and he's gonna introduce himself.
My name is Preston Shimura. I work at Lyons District 103. I'm a seventh grade math teacher.
Perfect. All right. So I placed the link in the chat. So with that link, you should be able to open the file with all the folder with all the files that we're gonna use throughout the activity. So I'm gonna share my screen. There you go. So we're gonna do optimal route. So you have a lot of information here. Okay, so for instance, so if you could open, okay, let's start first with this guy right here. Optimal road PD day 2022. All right. Now with this one, don't look at teacher pages yet. Okay, so go all the way down until you see the student handbook. This is the guy. Okay, so let me explain something before we get to this page. Okay, so pretty much all you need to know right now is that we're on page 6, I believe, page 6 on the
Got it.
student pages. All right, so now I want you to open the city map. This beautiful map that I create. So for instance, what do you notice about the map? Just at the top of your head, what do you notice about the map?
Trying to get online. It is definitely looks the streets are very square, which is pretty nice.
Okay.
There's a nice area that's right on the left side that looks like probably housing of some kind. There's a park between a bunch of expressways.
Perfect.
I don't see a lot of like businesses, but I'm guessing it's just that it's not listed on there.
Exactly. So the business is pretty much the layout of the blueprint. Okay, it's we're so far out, distance wise that you're not gonna be able to see, and that's something that once again, we're assessing pretty much the distance, and pretty much if you think about GPS, first of all, some of the students are gonna be familiar with GPS. Some of the students are not gonna be familiar with GPS because they don't drive. This is for middle school, so most middle schools don't drive. But they should be hopefully comfortable with the GPS on their phones, or whenever they're driving with their parents, or their brothers or whatever. So they should have an idea about GPS, and how does it work. So in this case, okay, I'm providing the city map, okay, the layout, okay, and also I'm providing the speed, okay, because in order for us to know the speed of something, we need to find the distance and we need to find the time. Now, with those two things, right, you're gonna be able to find the speed. In this case, the distance, you will provide the distance, and I'm gonna provide the time, okay, based on the speed. All right. So what we're gonna do, okay, we're gonna manipulate this equation to end up with time, because remember we're looking for time. So we have a speed, which is right here. I'm providing that, and you're gonna provide the distance, okay? In order for us to end up with the time. Most of the main purpose of the GPS is to find the route and to make it in the quickest time possible. So I'm not gonna go too deep into this, okay? It's for your free time reading. It will be right there the explanation. But in other words, you're gonna utilize the map, and I'm gonna provide a template for you to go step by step and find the time that is gonna take you to go from point A to point B. Okay. Now, as you can see right here, it says without hazard and with hazard. If you drive or you ride the bus or whatever, you're always gonna have situations that are out of your control. It could be, whatever reason, but it will be out of your control, and that's gonna affect your time of travel. Okay, so it's something very, very important that we always have to consider. So you're gonna have without hazard, so pretty much everything is perfect, and you can make it from point A to point B in 20 minutes or 30 minutes or whatever the case is. Now, it depends on the hazard. It could just add a couple minutes, or it could just add hours. I mean, that's a given and an unknown at the same time. So as you can see, you have 1, 2, 3, 4, 5. So 5 different cases. Okay, so before we get into too deep into this, I want you to go back to your map, to the city map. There you go. And I'm gonna give you a couple minutes, Princeton, to actually. I'm gonna give you a point of point A and a point B, and based on your map, you're gonna share with me, okay, with the class, how would you get from point A to point B? All right.
Okay, sounds good.
So the starting point is gonna be the corner of Jameson and Aurora. So the corner right here, Jameson and Aurora.
Okay.
And you want to go to College and Fusion right here. So I want you to analyze the map, take a couple minutes and see what route would you take to go from this corner to this corner. Okay? Any questions? Any questions, Preston?
My pen fell to the ground, so yes,
Okay.
no questions. I'm trying to figure it out right now.
No problem. So I'll give you a couple minutes. Let me know whenever you're ready. Okay?
Sounds good.
Okay.
I forgot my endpoint.
That will be Fusion in College.
Fusion in college. Yeah. My pen fell down when I was writing it. Okay, perfect. Sorry about that.
No, thank you. All right. All right, so share with us. Let me just, do you want me to open the map? Let me open the map. Okay, so what will be the first one, Preston? Well,
All right, so
let's just do one. Well,
so
let's do
let's
couple.
go
Let's do couple. Okay.
so north to Jameson to Adela's Circle,
Okay.
and then make the circle go over to College, and then south to Fusion.
Okay. So what is this pink?
I assume that that is a road out
Okay. Okay.
of a
That's
circle.
a good assumption. That's a good assumption. Yes. What else? So give me
The
another
other
one.
one I was thinking was south on Jameson to Sullivan Park,
Okay.
and then to Torquay, then over to Torquay, then south again to Impala, then Impala over to Fuego, north on Fuego to Fusion, and then Fusion and College.
Huge difference, huh?
That is a gigantic difference.
Well, I'm glad that you use this. Even though it's not a road, it's like a walk path, kind of like a bicycle path kind of thing. But if
Good to
nobody
know.
asks, like in this case, you can assume that it's a road. Now, with your kids, you can tell them that it's an emergency vehicle only. You can tell, if anybody asks. But in this case, it's gonna be difficult because you don't have it on your speed time right here. You have only roads, avenue, court, street, way, expressway, and highway. So in this case, if you don't have any of those, technically the pathway will be only for emergency vehicles. But I'm glad that you saw it and you utilize it. So yeah, no, this is good. And some kids will utilize it, same way you did, and some good kids will be like, well, I don't know what that is. But yeah, no, definitely it's a good thing. So now that we're familiar with the type of roads and that kind of stuff, okay. Now it's time for some hazard stuff. So if you can go to the file, to the folder, okay. If you can go to the folder, I need you to open the cards. Okay, it says optimal route hazard cards. So if you could open that, you will find your starting point, and this is where the 5 templates that I give you, this is where they come in. So
Okay.
you have you have the name of what's happening, you have your starting point, you have your destination, and then you have your incident location. Now I'm gonna ask you to do not look at the incident location first. Okay, try to go same thing that you just did right now. Go from point A to point B. Okay, where do I have to go? Okay, and where will be a good route to take? And then you can do it just mentally, and then look at these hazard reports. How am I gonna go with this? Okay, if you look at the hazard report, then you're gonna take a different route at the beginning. But it's up to you. You can just avoid that and then just tell the students and then give them a aha moment that guess what, now you have to reroute, or you can just take the whole information and put it in. At the end of the day, it's the same. Okay. Now, at that point, when I just asked you to go from point A to point B, I didn't give you any more restrictions, right? But at this
Nope.
point, we need restrictions because you need to provide the distance. I'm giving you the speed. You need to provide the distance. Do not overthink this template. Just go exactly what the prompts are telling you to do. Okay, and then you're gonna end up with your time. Now, something that you're gonna see right here is this string, centimeters. The reason why I'm asking you for centimeters on a string, or shoelace, or even the cable on your headphones, anything like that will work. Okay. And the reason is because I want you. Okay, yeah, Preston.
No, I'm good. I'm just
Okay.
saying yes.
I want you to look at your map. Oh, and also you need to download the ruler. Now, I don't think you need to provide this, with students, because if they have an actual ruler, that would be great. But just because of PD and when you're doing things online, everything has to be the same. Otherwise, data doesn't work. So I pretty much give you your 6-inch ruler. Okay. Now, since it's digital, well, I mean, obviously you can make it bigger or whatever. But if you just open it just like that, that will be a standard for everybody. Okay, so that would be like a 0 size. Okay. Are we okay so far with the
We're
instructions?
good.
Okay. So what you're gonna do, you're gonna take your map. Okay, you're gonna take your map. You're gonna take a piece of string, okay, cable or anything, whatever you have available. That is some kind of like a string or wire or something. And I want you to take your string. So for example, we're gonna just go from Impala to Sullivan. You're gonna place the string here, and you're gonna take it all the way to torque. That piece of string it will be a lot easier if you do it with a ruler, but we don't have rulers, and digital is a little bit tricky. So with a piece of string or wire or whatever, you're gonna measure this distance. You're gonna actually place it on top of your screen. Okay. Then that string, okay, that will be your distance. So you go back to your template. Hey man, go away. Okay. You go back to your template, and this is gonna be your string in centimeters. You're gonna take that number, you're gonna multiply by 25.25, and then divide it by the speed. In this case, if it's an avenue or whatever, I'm providing that information here. Okay, you're gonna put it right there. You're gonna divide it by that. You're gonna multiply it by 60, and then that's the time in minutes of that section. That little piece of section right here. But then if you turn, for example, I make a left turn, now I'm here. So now I'm gonna go north-south from here to here. And once again, you place your string, on top of it, and that's how much you're gonna pretty much do it again, so on and so forth. And then you're gonna measure it from here to here. Okay. Now, some students are gonna be like, well, I can just measure from here all the way to here. In reality, right? And then just do
Right.
one calculation, and then just go up top and do one calculation. However you want to do it. Okay, however you want to do it. But that's pretty much the task. Is with your string, you're gonna take your string, and then you're gonna use your ruler. Okay, you're gonna use your ruler for to measure that string. So that piece of string will be, I don't know, 5 centimeters. That's the number that you're gonna place on your template, or 7 centimeters. So whatever the case is. When you add every single section, you're gonna end up with your total amount of numbers that you're gonna need to go from point A to point B. Does it make sense,
Okay.
Princeton?
Makes sense. I'm writing down that I'm writing it down for my trip right now. And then I'm
Okay.
looking at the other thing, and I think I see, okay. So like the one thing I didn't notice, here it is. So streets and courts are different. Got it.
Yes.
Got it. Okay. So
So if you
end up
if
with a
you
lot
want
of
to take,
fractions.
yes, yeah, and once again, the kids will develop, the way to do it like easier and faster and stuff. But if you have to go, step by step, there's no harm in that. You can go step by step, section by section. But the key is to take the idea of the distance, measure the distance from a piece of string into centimeters in order for us to get to the time. because that's what's important for us right now. The time that it's going to take you to go from point A to point A to point B.
Okay, so like what I'm ending up with for that trip is about 3 minutes.
Perfect. Sounds great. Okay, so you get in the rhythm with this.
I'm getting the rhythm of this. Yeah,
Okay,
this is
perfect.
kind of cool. Okay.
Okay, so now why don't you take? I'll give you like about a few minutes or whatever. Let me know whenever you're done. Why don't you do two? Pick any two of the hazard cards. You have, I believe 10. Yeah, 10. Pick two. Okay, pick two and do it, and then share with us. What you found, what your findings. All right.
Okay.
So just take
Sounds
any
good.
two, any two, and let me know whenever you're done. All right.
All right, will do.
Okay. All right, person. What did you find? Let me
All
open
right,
the
so
map.
all right. So that first one, that's STEM and oh, so that first one, that's STEM and solar, a little bit south of here. All right, so the one that was STEM to Arita,
Okay.
going straight down would
Okay.
take about 4.5 minutes.
All right.
But if you have to go around it, so in other words, you have to go west on STEM Way, south on Acre, and then back east on Arita,
Okay.
that takes almost 8 minutes because of how much slowdown there is. Because you're really going only yeah, it's a very, very big difference.
Wow. Did you try
The other
yeah. Go ahead.
the other one, sorry, go ahead. What were you gonna say?
No. I was asking if did you try any with the highways?
I did not try any of the ones with the highways because I chose the first two, which really don't require highways. They're off highway. I
Okay.
decided to go the cheaty way, which I decided to take the I decided to go with a student's mentality of what's the easiest ones to do.
Yeah.
And the easiest ones to do was that one because it's straight versus going around.
Uh,
But the one I found more interesting actually was the Mars and Lobo to Fuego in Chicago.
okay. Lobo,
So
Mars.
I was going, yeah, I'm going that way to Mars, a little bit over. And
Okay.
then you would go to Fuego and
Okay.
south to Chicago.
All the way down. Okay.
Yep. And then there's a snowstorm, so that takes about 11 minutes. And because of the snowstorm, you have to go a bit slower, which takes between, so that same exact route
Mhm.
takes, instead of 11 minutes, somewhere between 12 and 13 minutes.
Wow.
So it's not a very big difference, but it's kind of interesting because that I like the snowstorm one especially, and I think
Mhm.
I would actually do this with the map of like the area we live in,
Exactly. Yes. Yes.
because I'm thinking I think that would be really, really awesome for them to see the difference between like traveling to their grandmother's house in
Yes.
nice weather versus not good weather, or like, for example, what happens in the great snow. Many of them lived through the great snowstorm of Chicago where everybody was going 5
Mhm.
miles an hour and it was taking people 3 hours to get home.
Yeah.
Because a lot of them were complaining about that recently. So I think that this would actually, with that complaint, I think this one is really, really great for like proportions
Yes.
and using an equation. I think that would be really I can definitely see where I would use this.
Yeah,
And
no,
even
this
more
is great.
interesting is that, and even more interesting is that this fits in really well with the other IMSA, that work challenge thing that we did last year, where we
Okay.
were designing a city.
Yes,
I
yes.
could imagine them taking this, so they've already worked on designing a city. I could see them taking this and doing, like, how would you deal with these hazards that occur in your particular area very often?
Oh, especially if it's their own area. I mean, if it's their own Melrose Park or whatever. I mean, it would be really easy to find the layout, the
Right.
blueprint of the area. I mean, it could be on the internet. But then, like for real, I mean, if you live here, imagine if you live, all you have to do is just cross the park, right?
Right.
Imagine you go from Main Street and Peters, and you have to just go across to Power, for example. Well, if
Yeah.
it's a nice day, they can you just go across, right? No problem. But how
Right.
about if you have to drive? You have to go all the way down to Impala or Chicago, all the way around. And that happens in Chicago. I
Yep.
mean,
All the time. Yeah.
all the time. I mean, or you have a one way. So if you're
That's what I
going
was
home,
thinking. Yeah.
if you go back home, then you're gonna be there in 5 minutes. But if it's a one way and you have to go all the way around, now you're talking about different situation. So no, and now think about the highways. If you have to go, for example, from here to the top left corner of the map. Well, if you can get in here, drive 60 miles an hour, and then somehow make a turn this way, but just
Right.
because of this curve, I'm assuming you cannot just make a left. I'm assuming it's gonna go one way. Now it doesn't. It's not really that specific, here. But if that's the case, this is not an option going this way. It will be more an option going down, to the right, and then connect, and then make the turn. But just the difference in time between street roads and a highway. I mean, that's a key, and it's something that the kids don't realize because again, they're not driving at this age. If we do like middle school, even high school, I mean, they have to be what, almost juniors, sophomore, almost a junior in order for them to drive. So yeah, but I mean, it's amazing how when you calculate it, I'm sure that at first you're like, that's too many calculations, too many variables, and how you gonna end up with a number, and then it's just the way we design the template is for you to don't overthink and find a number with a hazard and without a hazard.
And I think the idea of tossing in, like, having all of them do the same destination, same hazard, same starting point. I'm sure we would get, other than, like the ones that I use that were
Yeah.
cheaty. I would not let my kids, choose. I would tell them the destination, the starting point and the destination, to make ones that they can go different directions. So
Yes,
we could actually debate which is the best direction.
exactly. Now imagine, I mean, you can take it to the next level. Imagine if you're a police officer or an ambulance or a fire truck. How would that change? How would that change?
That's
I
true.
mean,
Yeah, you can go
they
pretty
don't they
much the
don't
same.
stop,
Right.
but how is that gonna change? It's the same distance. Many people would be like, oh, because they can. Well, it's the same. If it's 20 miles from point A, from point A to point B, doesn't matter if you have the sirens going or not. Still 20 miles. So the distance is not gonna change. But what's gonna change? The speed. So
Right.
instead of it driving, 20 miles an hour, 30 miles an hour, I mean, that would change. Now that could change though, because if you're in the city, Chicago, New York, I mean, if the traffic is back to back, I don't think you're gonna be doing 20 miles an hour, even if you have the sirens going, because there's no room for traffic to move, even if they want to get out of the way. So that's
No,
a lot of variables that those are good variables, conversation points.
I'm thinking of how this would be extremely useful. I like this.
Yes, and it's a very, and many teachers will argue, not argue. But we'll disagree with the fact that if you think about it, the same equation here, okay, pretty much I chop it and I organize it in a way that will be easier for they to think, no, time and stuff like that. So it's guided to end up with, the time. So many teachers would disagree that this is the best way because you're not assessing the formula, but what are we assessing? That's the main point.
Well,
What are
and
we
I was
assessing?
going to say that this is something I can imagine using with my students, especially the ones who are a little bit more questioning of formulas.
Yep.
Like for the advanced kids, I would definitely have them calculate it themselves.
Yes.
But for most of my students,
Mm-hmm.
I would absolutely, I might skip the first one, the string to multiply by 0.25, just because I would like them to be able to
Yep.
understand scale.
Yep.
But I would use this to test on scale and their ability to find, to logically find an optimal route. I think this could
Yes.
be, yeah, this could definitely be useful for when social studies and I collaborate on maps,
Yes.
because they do a whole section on maps. We double it up, math and science. That would be
Mm-hmm.
really, I like this. I probably will use it not this year because we already did that, but
Mm-hmm.
maybe next year.
Yeah. No, definitely. It's something that and that's the the beauty of when you have something like this, that it's open. You can take it however you want. Whatever topic, you can utilize the fact that what I mean, we need another highway. Why do we need another highway? Or nobody uses this section or whatever. Well, it's not that you're gonna just take it down. You're just gonna close it. But how about if we need another highway? Where would you put another highway? What would be a good reasoning for it? What I mean, is it good? Is it not good? Is it what I mean? So again, it's something that it changes your perspective about just the whole social aspect of it. But now this is pretty cool. Now, feel free to change. These numbers are pretty much like standard numbers. What I mean, like based on highways and stuff. But during traffic, I mean, you can change those numbers, and I really like the cards because it gives you a different situation. Based on local stuff.
Yeah.
Now you can place this into a PowerPoint. So like you were saying, like all the students will do the same. If you're gonna do a PowerPoint, something cool that you could do, block this section right here. Don't do the incident yet. And then whenever they find the best route, and then boom, you throw the incident. So they have to reroute.
Like that. I like that a lot.
So that's how I do PD, only because we're I have only an hour with you guys, with you, and we have a bunch of stuff. But otherwise, during PD, I will totally just block this. I'm not a destination. I'm sorry, the incident. Boom. So you think you're gonna be finished? Oh, I'm done. But then boom, this is the incident. Now it could not, maybe not, didn't affect you because you didn't take that route. But if it did, something that is kind of, once again, try to relate it to real life. The whole point with the string is when you put in your GPS, you want to go from point A to point B. Do you see the blue line that you're traveling with, and it's following you and it's guiding you? That's the whole point of the string. I mean, besides, because you can take the ruler and just measure right on top of your map, to get your centimeters. But the whole visual of the string is that's the connection between what's happening on your phone or your GPS or whatever versus what you're doing it by hand.
Big fan of that. Okay.
Okay. And
Sounds
then
good.
yeah, something that usually you might want to do with your kids. And again, this is just for fun, and doesn't matter if they're high school kids or or elementary school, they will love it the same way. Usually I ask the students, for example, you're doing this one right here, the when it rains, and then you got your destination, right? You went from point A to point B. It's gonna take you 40 minutes. But then I'll throw the incident, like on a PowerPoint. Boom, it's gonna show up. And if you have to reroute, I ask the kids to stand up, open their arms, okay, and and just turn, just make turns like that, spin around. And the reason is because one is fun, two is movement, and three because when your GPS reroutes, you see the little circle going around, right? That is looking for the next route. That will be the idea of the kids pretty much then stand up, and start turning around. And they can even, say like, rerouting. Again, it's kind of silly, but the kids are gonna love it.
I was gonna say my kids would definitely buy into that. I didn't think of that possibility. I'm writing that down. I love that.
Yeah, and especially right now, for example, we have been in session for what, almost 6 hours. If we were to be a face to face, we will be rerouting right now. Like adults, doesn't matter. You just stand up, and that's the whole point. Again, it's connecting what they see on their phone and their tablets to real life. You know what I mean? It's kind of like the idea. Pretty much. Good, good, good. Any questions, Princeton, before we move on?
No, I'm good.
Perfect. I'm glad you like this one. All right. So for the next part, let me check the time. Oh, I have only 10 minutes. Okay. So I'm gonna go not too deep into the next two, but I just want you to at least to present it so you can see it. Okay. So let me close this down. Uh, yeah, it took me a while to develop the map. I mean, it's a little bit different, yes. Okay. So I'm gonna show you just real quick two activities that I want you to see. I'm gonna go with the first one, which is okay. If you want to open this one, it's called Transition Signal Network. Traffic signal network. I'm gonna
I
just
got
touch
it
base on
open.
this one. Yeah, I'm just gonna touch on this one real quick. And I don't know if you already done it for this year, but remember the if then statements. If then, if this, then that happens, so on and so forth. I don't know
That would be
how.
more my wife's. That would be more my wife's thing. But I'm seeing this as more of a wife, the computer skills STEM class.
Yeah. Well, this one is that one is definitely, and feel free to share with her. But this one is also when you talk about proportions and synchronization. Synchronization is one of the toughest parts on any kind of mathematics, science, anything. When you try to synchronize something, it's a challenge. So in this case, and I have all the explanation and everything here, but we're looking at the if-then statements. So let's assume this is your stoplights, right? You have your stoplights, in every single corner, and so on and so forth. And you try to, based on predictions, how can you synchronize these stoplights? So you have 1 through 8. You have 8 stoplights. How can you synchronize them? For example, if you're gonna make a right turn, you're gonna make a left turn. How can you synchronize those? Now, I have a specifics. For example, you cannot alter the road, so you cannot just change the road. Every vehicle takes approximately 3 seconds to go across the intersection. You cannot feed more than 5 or 6 vehicles at a time. for you not to block the intersection, so on and so forth. So it's just some of the limitations of the program. But if you think about numbers, okay, so it's 3 seconds per car, and I have 1, 2, 3, 4, 5. So 5 times 3, 15, so on and so forth. So it's gonna take 15 seconds for all these cars to go through. So again, it's just thinking about numbers, thinking about a lot of hypotheses like, well, if this, then that. How many cars can you fit in on the road? So again, it's not really uh, there's no right or wrong answer, because I mean everything is a lot of hypotheses. But what you're looking for is that uh, the mentality of starting with a hypothesis, and just if you think about the like a graphic organizer, if this, then you go to the right, if not, you go to the left, so on and so forth. So again, this will be very good for computer science, but definitely for math, for the math purposes. And also I have two samples done by middle schoolers on how to answer that. You know what I mean? Like, well, if this, then that, so on and so forth. So it's a pretty cool activity. Okay, it's a pretty
Well,
cool
it's very
activity.
interesting. I like it.
And again, it's one of those things that seems to be simple, but it's complicated, and it's totally connected to the career education. A lot of the stuff that we're doing nowadays is connected straight to careers education. Not because we're not pushing kids to go to a 4-year college. That's not the case. But we need to have options. Okay, we need to have options, and this is one of the ones. Like I mentioned earlier, um, down the road, we're not gonna need engineers. You're gonna need, programmers to deal um, with the stoplights and all the stuff. So it's definitely something that the kids need to they will have a chance uh, to go and to explore that. What do you think about
Okay.
it, Preston?
I think I like that, especially because it is not particularly high level math.
No.
It's deeper thinking without the high
Yes.
level arithmetic.
Yes.
I really like, so I will say, I having worked both urban and suburban, I think
Yes.
a lot of my urban kids would really have gotten into that one, because it's something that they deal with on a daily basis, even walking,
Uh
like,
huh.
even walking across roads, trucks, cars get in their way
Hmm.
because of improperly placed, or
Exactly.
improperly timed. No, I think that one, I don't know what my current kids would think of it, but I know my urban kids would have loved that one.
Well,
It's a
actually,
very good
one of the
call, but the
extensions.
thinking is deep.
Yeah, one of the extensions, and it's something that we don't realize, but one of the extensions is to actually take the kids, not close to the sidewalk, obviously, but a little bit far away from the stoplight, as long as you can see the stoplight. Take a timer, take a timer, and try to find a pattern. So click on the timer. How long does it take on for the thing to change to from green to red, whatever, back and forth? Did you find a pattern based on traffic, based on whatever? Because they don't know about like having sensors and motion sensors and all the stuff in every corner. But just a plain timing, trying to find a pattern at a stoplight. By the fact that you're taking it away from the classroom into the street. I mean, like, it could be right in front of as long as you can see the light changing, so you don't have to be right on the sidewalk. But again, it's just you know taking the theory into the street and see if that works. Why does it work? How come it doesn't work? What do you think about that?
Yeah, I'm thinking that's literally where I was going with it, which is that not my current school, but my previous school was literally on the corner of a road where we could have gone out and
Yep.
counted the number of cars going by
Exactly.
versus the clock sitting there and taking data. I think that
Yep.
I'm trying to think of how I would do it at my current school, but my previous school, that would have been absolutely, if I had gotten it 2 years ago, this would have been 3 years ago, this would have been absolutely perfect.
Yeah, but try and find a way. I mean, I'm sure
I'm
when
sure
the
there's
weather
ways.
is nicer, maybe like a block away. I mean,
Well, that's what I'm thinking I
you know
could
what I
do
mean?
it because I think we could still see the lights.
Yeah,
And
as
we
long as
would
you can
just
see
say
it.
if they're red, assume if they're red in one direction, they're green in the other.
Yes,
And
yes,
we can
yes.
count the number of cars that go by.
Yeah, maybe a group of kids will count or time the lights. Some of the kids will count the cars. Some of the kids will count pedestrians if that's the case. You know what I mean? Like try to find a pattern without any expectations. Find patterns. That's key in mathematics, and it. It's trying to find a pattern and try to use your reasoning, not just like, well, it takes 4 minutes. Well, no, not gonna take 4 minutes every single time. You know what I mean? Because you have a bunch of sensors and you have a bunch of all the stuff. For example, motorcycles. Motorcycles, they can actually take a red light. Why? Because they don't have the weight for the light to change. So I mean, it's just something like when you see a motorcycle, hey, wait a minute, he took the red light. Well, no, it's because he was waiting for a half hour. The light's not gonna change. So it's based on weight.
Interesting. What was the other one that you were
Oh
going to
yeah.
present?
So this one is again. This one is actually I created a video. Okay, and this is gonna be the template. So this is the template. Okay, you're gonna print it. Okay, and ask your kids to cut them. So you're gonna cut this, and you're gonna cut the steering wheel. Okay, you're gonna cut it, and then you're gonna put it together. Okay, how you gonna put it together? Pretty much you're gonna center one on top of the other. Give me 1 second. Okay, you're gonna put one on top of the other. So the circular transporter is gonna be at the bottom, and the steering wheel is gonna be on the top. Okay, you're gonna end up with picture. There you go. Here. Okay, can you see it, Present?
Yep, I can see
Okay,
it.
so pretty much the bottom, the big one is gonna be at the bottom, and then your steering wheel is gonna be on top. Okay, and then you can use just like a fastener, like a paper clip or anything that will hold it. Okay, so pretty much you're gonna be able to turn your steering wheel, and this arrow is gonna tell you how many degrees. Okay, how you move your steering wheel. So if you think about driving, every time you have a turn, it's not the same to go on a sharp turn than to go, a soft turn. Why? Because the amount of degrees that you need to move your steering wheel will vary. Okay, are we okay so far?
I got this.
Okay, so now this is gonna be in partners. Okay, one kid is gonna actually take the wheel and actually drive, believe it or not, and the other kid is gonna pretty much observe how many degrees, pretty much the movement, describe the movement. Wherever you see how this thing moves, you're gonna write it down. Okay, once again, we're attaching mathematics with data collection, with data analysis. Okay, so are we so far so good with this?
Got it.
Okay, now you're gonna have a video. So pretend that you have your template, right? Pretend that you have your template and you're driving. Okay, there you go. You're driving and you're moving your steering wheel. So let's assume that you're driving and I'm taking notes. So my notes will be like, it moved 20 degrees, it went back to 0. Speed was 25. It moved to 200 and something degrees, right? So pretty much from 0 to 270. Sharp curve downhill, all the stuff. And then your kids are gonna love it because they're gonna go in the highway.
On side streets. This is kind of cool.
So then, you know, you make a turn, be careful with that car. Okay. So they're going to be, they're going to love it because they're going to be actually driving at, you know, middle school or elementary school. And then, you know, you're going to be driving. The key is to take notes, good notes. You're making a left, you know, right now you're moving maybe like what, 5 degrees? You're staying wheel,
Yeah.
go back. Okay. And then you're going to speed up and you're going to see all these cars coming. You're merging, so I'm assuming you're gonna move a little bit.
Oh, and you're gonna turn. Are you gonna change lanes?
Yeah. And then
Oh.
you know how big of a
Oh.
turn, how big of a movement was right there. That was actually me driving, and my nephew taking the video.
Gotcha. This is okay. Yeah, I could imagine.
And once again, this is critical thinking. It's not even. I mean, we're using math. You know, we're using math, but in reality, that's critical thinking, like you mentioned. It's taking it to the next level. It's not on paper. It's not, you know, well, it is on paper, but it's not, you know, just like that. It's an actual movement, an actual, you know, taking the kid out of the comfort zone to make it to make it pretty cool.
This is really, yeah. I'm thinking of using this one. So all three of the things you've done today is something that I have a place I can put for the rest of the year,
Perfect.
and it would actually. Yeah, I mean, most of the stuff early in the year you haven't gone over, but this is the time of year I really love to do hands-on things. I love doing it throughout the year, but right now, especially because
Mm-hmm.
they're a little bit antsy. And
Yes.
so
Yes.
more hands-on things, less, you know, deeper thinking, more
Mm-hmm.
movement is a good thing this time of year. I like all of these that you've done
Perfect.
today.
Perfect. Well, I don't keep you, you know, longer. I already went 5 minutes over, but you know, I mean,
That's
you can
fine.
read it, but then you know, like how, what? But you know, now when you see it, you know, when you know it's been explained to you, then it'll be like, oh, okay, so that makes, you know, that makes more sense. So no, this is cool. Thank you very much for your time. Feel free to go back to the room. I think it's still open. So you can finish your CPU stuff and all that good stuff. You have my email, so please send me any information, questions, or whatever you need. Let me know.
Sounds good.
Thanks a lot for your time. Have a great day.
You too.
Bye bye.